Hello everyone and welcome to the virtual pre-conference course on electrosmog and electrotherapeutics 101. What doctors need to know about electromagnetic frequencies in this wireless age. This course will be held over 2 days and will consist of 4 hours of instruction and 2 hours of questions and answers. For those who qualify, this course is equivalent to 4 CME credits. Today we are going to have 3 40-minute lectures on the big picture, followed by radio frequencies, microwaves, and 5G, and then we will discuss extremely low frequency electromagnetic fields. After a short break, we will have a 1-hour Q&A session. Tomorrow we will start with dirty electricity, then we will discuss ground current pollution, and we will end with electrotherapy and frequency therapy using light, followed by our final Q&A session. Electromagnetic hygiene is the missing link to vibrant health. For that reason, it is important that doctors and those in healthcare educate themselves about the biological effects of electromagnetic pollution in its various forms. If you haven't already done so, please consider signing up for the virtual EMF Medical Conference to be held January 28th to the 31st, 2021. To make these sessions more interactive, we are going to have a few polling questions sprinkled throughout the course. The black transition slide indicates a polling question is up next. Ben Levi is helping behind the scene, and he will post the polling question for a few seconds, and then we will instantly see how people have responded. Note that all the responses are anonymous. We have 4 polling questions for you to answer now. We are going to start with the big picture and examine how the various types of electromagnetic frequencies generated by both natural and man-made sources interact with each other. The sources of electromagnetic energy fall into 3 categories. Geofields, these are natural non-living sources of electromagnetic energy. All living organisms generate biofields or bioelectromagnetic fields. And finally, there are artificial fields generated by our technology, which I call technofields. These are some of the more common natural non-living sources of electromagnetic energy that we get from the sun, solar flares, from the cosmos, from the northern lights, lightning, the Earth's geomagnetic field, air ionization, and Schumann resonance, or the heartbeat of the Earth. And all of these are biologically active. What I mean by that is that these fields have biological effects, and there is a lot of information about this in the scientific literature. I elaborate on air ionization just to provide an example of how these sources affect living organisms. When we are in an environment with a predominance of negative ions, we feel good. This is because most common in nature, and it is in direct contact with the earth as we walk along a beach or lie on the grass. When positive ions dominate, some people feel unwell. And this situation is more common in built-up environments with our synthetic clothing and footwear. A very interesting paper published in 1974 stated that 25% of the population complains of weather sensitivity due to serotonin irritation syndrome when they are exposed to positive ions. Negative ions provide both prophylactic and therapeutic results to 75% of the subjects tested in this study. I experienced this firsthand in Poland a few years ago. I was invited to a conference, and during the conference I developed a headache, which is rare for me. I felt weak, dizzy, tired, achy, as though I was coming down with the flu. I asked our host if she had any aspirins, as I don't travel with them, and she told me that we were having a föhn wind event and that I must be sensitive to positive ions. Negative ions are common near waterfalls and during rainstorms, and positive ions are common in urban centers, as can be seen in this table. This could be one reason why going for a walk in nature is so refreshing and rejuvenating for many. When 2 people shake hands and they are at different electrical potentials, electrons are going to flow to equilibrate the 2 people. So just by touching someone or something, you can change your electrical potential and possibly your health. Touch is an important need for all mammals, and there is some evidence that electrons may be acting as antioxidants and affecting your health in a profound way. Air ionization also plays a key role in cloud formation, thunderstorms, and other weather events, and the ionosphere is used to bounce radio signals around the globe. Our atmosphere and the Earth's magnetic field provide a fairly good shield against some of the radiation that comes from outer space, since not all of this radiation reaches the Earth's surface. What this slide shows is that light frequencies penetrate to the surface of the Earth, and that is why we can see the sun and stars. Some infrared and ultraviolet also penetrates, but most of this radiation is blocked. Also, a part of the radio frequency microwave spectrum penetrates to ground level, and we have radio telescope that listen to whispers, a very weak signal from outer space. One such telescope is at Green Bank, West Virginia, where there is a radio exclusion zone. No cell phones or other wireless devices can be used there because the signal interferes with the radio telescope. Consequently, it is a good place for those who are electrically hypersensitive to go to recover. All living organisms are beings of light and have electromagnetic energy flowing through their body. Every cell has an electrical potential difference across the cell membrane. Once a cell's electrical potential gradient begins to approach zero, that cell will die. Similarly, it is possible to charge up a cell to make it more healthy. Our heartbeat is electromagnetic. Biophotons produced by the body are electromagnetic, and this is based on the work of Fritz Popp. Brainwave activity is electromagnetic at extremely low frequencies. Infrared radiation or heat is part of the electromagnetic spectrum, and this heat provides information about the body. With Oriental medicine, we learned that acupuncture points have a higher conductivity than surrounding cells, and that is why we can find the acupuncture points using electroacupuncture. Other species can also use their electrical energy in a variety of ways. And even the simplest organisms have magnetoreceptors to help them navigate. Here you see a string of magnetite crystals in a bacterium. Magnetite is found in the brain, abdomen, or thorax of many different species, from birds, bees, butterflies, to migrating fish and amphibians. As an aside, anaerobic bacteria that are poisoned by oxygen and need to live in an anoxic environment, behave differently if they are in the northern versus the southern hemisphere. Those in the northern hemisphere move towards the north pole of a magnet, and those in the southern hemisphere move towards the south pole. When an environment is disturbed, these bacteria need to move into a low oxygen environment. And that happens to be more common at increasing depth in soils and sediments, and even in some bodies of water. Consequently, by moving towards the poles, the bacteria are burrowing deeper into the sediments where there is less oxygen, a definite evolutionary advantage. While we can discuss these fields in isolation, what becomes particularly interesting is how these fields interact. Geofields and biofields can interact as shown by the overlap of the two Venn diagrams. Some of these interactions are beneficial and some are harmful. Biofield interactions are also possible, like therapeutic touch, as are geofield interactions. The Earth's magnetic field shielding us against the solar wind is a prime example. I asked earlier about polar reversals. This represents the magnetic lines of force around our planet. You can see predominantly yellow or north magnetic field and blue or south magnetic field predominating at the poles. During a polar reversal, the magnetic field weakens considerably and then strengthens again, but with opposite polarity. Based on geological records, the Earth's magnetic field has flipped several times in the past, and some of those flips coincided with massive extinctions. The concept here is that a weak magnetic field is unable to shield the planet against harmful cosmic radiation, resulting in extinctions. Currently, the Earth's magnetic field is weakening, and we are overdue for another polar reversal. During these reversals, it is the magma in the Earth's center that shifts and not the continents, as shown here. And finally, there are technofield interactions. Normally refer to these as electromagnetic interference, or EMI, if it is negative. Driving under or near power lines while listening to an AM radio station causes static and electromagnetic interference. Placing your cell phone in airplane mode is supposed to prevent any interference while on board an airplane. Most of this course is going to be dealing with technofield-biofield interactions that are either negative or positive. Biofields can also affect technofields, so this is not necessarily a one-way effect. In the past, when we had rabbit ear antennas on TV sets, a person could adjust the reception of the moving antenna, and sometimes the best reception was when the person was touching the antenna. In other words, the human body was working as an antenna and improving reception. Electrosmog is a form of air pollution. We get it from stationary sources and from mobile sources. We can have indoor air pollution as well. Mold, chemicals from paints to pesticides to cleaning products can all pollute our indoor air quality. Hospitals are aware of this, and many now have signs to keep a fragrance-free environment for those with multiple chemical sensitivities. That is why it is so hard for us to watch as hospitals increase their use of wireless technology and contaminate with microwave radiation hospital rooms, intensive care units, waiting rooms for patients who are already ill and can't tolerate more attacks on their body. Hospital staff also deserve to be working in a clean, safe hospital environment. Smart homes are electromagnetically unhygienic and should be avoided as much as possible. Do you have electrosmog in your clinic? How far is your clinic from power lines, cell phone antennas, wind turbines, and solar farms? Have you checked the wiring in your clinic? What type of lighting do you use? Do you have smart meters and smart appliances? And finally, do any of your staff or students wear wireless wearables? And do you have other wireless technology in your clinic? Chances are the answer to this question is yes, and it is important that you reduce your exposure as much as possible to accommodate your sensitive patients and for the health of you and your staff. When we look at the history of electrosmog, it began about the turn of the century with the introduction of electricity. We use 60 Hertz in North America, and most of the world uses 50 Hertz for electric power. Originally, it was 25 Hertz, but too many people got headaches because the light bulbs would flicker noticeably at this frequency. Based on the work of Tesla and Marconi, we began to send radio frequency signals around the world, and AM radio stations began to appear in the 1920s. During World War II, radar was invented, and this uses microwave frequencies. During the 40-year period from 1980 to the present, use of personal computers, energy-efficient lights, cell phones, Wi-Fi, wind turbines, solar farms, and smart meters have increased dramatically, and all of these contribute to electromagnetic pollution. As of 2020, we are being exposed to 5G technology that includes millimeter waves and the Internet of Things. Here is a graph from the World Bank showing the number of cell phone subscriptions per 100 people in 4 countries. During the 10-year period from 1995 to 2005, cell phone subscriptions in the United States increased from less than 10% of the population to about 70%. In the next 10 years, this increased to 120%, indicating that some people have more than one cell phone subscription. During the same time, the number of antennas increased as well to service the cell phones. So our use of cell phones has significantly increased our microwave exposure. And then we had Wi-Fi. This map of the world shows the Wi-Fi locations in 2004 being predominantly in the United States and Europe. Within 14 years, our use of Wi-Fi has exploded globally. Combine this with cell phone antennas and cell phones, with smart meters and smart appliances, with wearables and 5G, and the question we need to ask is, how much more exposure can we tolerate before we all get sick from this radiation? I classify electrosmog into 4 categories, and all of these contribute to chronic illness. Extremely low frequency electromagnetic fields, radio frequency and microwave radiation that includes 5G technology, ground current pollution that few people know about, and dirty electricity that is generated by the many devices we have in and near our home. Let's turn our attention to the electromagnetic spectrum. The EM spectrum is arranged by frequency and wavelength, with higher frequencies and shorter wavelengths near the top of this graph. The spectrum is split into ionizing radiation and non-ionizing radiation based on the energy of the photon. When scientists are discussing this part of the spectrum, they use frequency, and the various units are provided here. When they are discussing this part of the spectrum, they use wavelength. And finally, when they are discussing ionizing radiation, they may refer to electron volts rather than either frequency or wavelength. Being able to convert from frequency to wavelength is important, and there is a very simple equation. Frequency times wavelength equals the speed of light. To answer this question, what is the size of a 60 Hertz wave? We can go to this figure and we can see that the answer is between 1,000 and 10,000 kilometers. To make a more accurate calculation, we need to plug in the values into this equation, and provided we have the right units, we should come up with the right answer, which is 5,000 kilometers. So a 60 Hertz sine wave is 5,000 kilometers long. In a similar fashion, we can ask the question, what is the size of a 2.45 gigahertz wave, which is used in microwave ovens, Wi-Fi, and some cordless phones? The answer is between 1 meter and 1 centimeter. More precisely, it is 12.2 centimeters long. This information becomes important when we discuss resonance effects. Antennas work best when their length is the same, 1/2 or 1/4 of the wavelength being transmitted. This information also becomes important when we discuss near field and far field effects. Part of the spectrum are given names. The ones outlined in orange are the ones we are going to discuss in this course. And this is how the frequencies that we are going to discuss fit together. We have extremely low electric and magnetic fields. We have radio frequency radiation that is subdivided into microwaves and millimeter waves. We have intermediate frequencies that further subdivide into dirty electricity. These have various applications and a variety of biological effects. For example, we know that ionizing radiation can alter chemical bonds by dislodging electrons from their orbits. There is a heating effect that extends into the upper part of the non-ionizing spectrum. At lower frequencies, we have electric shock. Heating and electric shock are the foundations for the guidelines that we have for electromagnetic radiation in North America. We have evidence of oxidative stress within the realm of ionizing radiation, But what most engineers don't realize is that oxidative damage extends throughout the entire EM spectrum, and this is based on biology, not physics. All parts of the electromagnetic spectrum are biologically active. Here we have a summary of the sources, frequencies, medium, and units for the different types of electromagnetic pollution. Extremely low-frequency electromagnetic fields are generated by our use of electricity, and this part of the spectrum refers to frequencies that are less than 300 Hz. The energy flows along wires and produces a field immediately around those wires in the air. Units include volts per meter for electric field and either Gauss or Tesla for the magnetic field. Both Gauss and Tesla need to be capitalized as they are named after scientists. 1 microtesla is equal to 10 milligauss. Dirty electricity is generated by electronic equipment and by shorts in electrical wiring and by turning appliances on and off. Dirty electricity flows along wires and radiates from those wires into the air. Units include GS units and voltage changes over time. Radio frequency and microwave radiation differ only in their frequency ranges. Both travel through air and are measured as volts per meter or as power density, watts per meter squared. Millimeter waves range from 30 to 300 gigahertz. They flow through the air and have the same units of measurement as radio frequencies and microwaves. And finally, ground current comes from our use of electricity, and this includes both clean electricity and dirty electricity. In this case, the electricity is not flowing through wires, but along the ground and along metal objects used for grounding. The units are amps if we are measuring current, and volts per meter if we are measuring voltage. We can convert from voltage to current if we know the resistance of the conductor. The biological effects of any part of the electromagnetic spectrum is a function of wave frequency characteristics. And here are some of the most important characteristics to consider. Some effects are frequency specific. Here we have an example of 2 waves with one at a higher frequency than the other. If we assume that the time scale represented by the box is 1 second, then the wave at the bottom is at 1 Hertz or 1 cycle per second, and the wave at the top is at 7 Hertz or 7 cycles per second. In biological sciences, we have something called frequency windows, where the biological response only occurs within a narrow frequency band and disappears at higher or lower frequencies, and sometimes reappears as harmonic frequencies. If F1 is 16 Hertz in this example, then F2 would be the harmonic at 32 Hertz. Intensity or amplitude is the strength or magnitude of the field. This is equivalent to the concentration of a chemical. This slide shows 2 waves with low and high amplitude. From a biological perspective, the peak-to-peak magnitude is what is important. However, engineers use root mean squared, which gives a much lower value than peak-to-peak, and thus underestimates the response. Here we have a typical dose-response curve for chemical toxicity. We have a threshold below which there is no response, and the higher the concentration, the greater the effect, until the curve flattens out as no additional response is possible. With electrosmog, we have something called intensity windows, where a specific biological response will occur only within a narrow intensity band and disappears at higher or lower intensities. Waveform, or the shape of the wave, is biologically important. Here are some common waveforms: sine, square, triangle, sawtooth. This will become more important during Lecture 6 when we discuss pulsed electromagnetic field therapy. The sawtooth wave seems to be the most irritating, and the sine wave seems to be the most soothing biologically. Modulation is also important, and here we have a carrier wave and a modulating wave. 2 types of modulation are common. Amplitude modulation looks like this and applies to AM radio stations, for example. Frequency modulation refers to FM radio stations, and their call sign is their carrier frequency. We can have continuous waves or pulsed waves. Microwave ovens use continuous waves to heat food, while Wi-Fi and other wireless technology use pulsed waves. Pulsed waves tend to be more harmful biologically than continuous waves. If we could convert these frequencies to sound, this is what they would sound like. Most of us have these devices on 24/7, and if we could hear them, it would drive us crazy. The duty cycle refers to the percentage of time during a period that a device is transmitting. This becomes important when we discuss smart meters. 4 different duty cycles are shown in this slide. A period is the time for a cycle to repeat. Assume all of these are at the same intensity, namely 500 units. The intensity of a signal is averaged over the entire period and hence gives a much lower reading than the peak value. So for a 10% duty cycle, 10% of 500 is 50 units, and that is how engineers would calculate exposure. At 30%, the exposure would be 150 units, etc. All of these values are less than the actual peak value during the period, and remember that living organisms respond to extremes and not averages. Waves can interfere with each other. There are 2 examples of interference, constructive interference and destructive interference. With constructive interference, the peaks and values are aligned, giving much higher amplitudes. With destructive interference, the peaks overlap with valleys and thus cancel each other out. This is how noise-canceling headphones work for sound. Just as waves can interact with each other, they can also interact with their environment. Visible light is part of the electromagnetic spectrum, and we know that light can be transmitted, reflected, focused, and absorbed by different objects. If we replace light with microwaves, we know that microwaves can be transmitted through buildings, reflected or focused by metal objects, and absorbed by water. A metal object can reflect, block, or focus radio frequencies, and that includes metal objects in or on our body. A major concern for students with braces or metal implants who are attending school with Wi-Fi. The Wi-Fi frequencies can reverberate through the brain. I know of one student who would pass out in the hallway of her school if she stood near a Wi-Fi base station for any length of time. Whether the frequencies are coherent or incoherent can also influence the biological response. One way to think of this is by using sound. Music is coherent and noise is incoherent. Combine this with an irritating frequency and the effect is magnified. Time of exposure is important, and this is based on a combination of circadian rhythm and the Chinese biological clock. The worst time to be exposed to electrosmog is during sleep when your body is repairing itself. Anything that interferes with sleep is also going to have adverse effects. Duration of exposure and cumulative exposure are important from a biological perspective. Taking breaks, digital detox, provides an opportunity for the body to heal. And finally, your location on this planet can affect your response to electrosmog. I'm not referring here to the amount of electrosmog in any location, but rather to the strength of the magnetic field. Dr. Abe Leboff found that the local magnetic field can influence the resonance frequencies of certain ions that are biologically important, like calcium, magnesium, potassium, and sodium. If we combine all this information with our electrosmog exposure, it's clear that we are talking about something that is very complicated. How on earth can we make sense of all of this variability? The good news is that despite the different exposures, the effects appear to be similar. For example, leukemia has been documented at various frequencies. The same applies to miscarriages, sperm damage, and infertility. The bad news is that when it comes to electrohypersensitivity, we have evidence that this radiation impacts almost every system in the body, from cardiovascular, neurological, hormonal, to immunological. The great unknown is how we react to millimeter waves. All of these effects have an underlying mechanism of oxidative stress. Our next session will be on radio frequency and 5G. We'll take a short break.